Hi there everyone, this is Ritu for Sharon and this is the demo video of my project Automated Machine Learning. Right now only the added users can get entry into the platform and the platform solves the supervised machine learning problems, that is regression and classification problem, and one unsupervised problem, that is customer segmentation, and adding which will also add customer lifetime value to for each segment. And I have added two supervised problems here. Siemens strength prediction, that is a regression problem, and forest cover, which is a multi-class classification problem. The projects can be added from here by giving the title, description, the regular expression of each of the file name, training schema, and the prediction schema will include the sample file name, the number of columns, column names, column data types. The problem type should include the type of the problem, and cloud platform should be selected wherever you want to store the files on the cloud. After that, the projects can be configured for adding files for the training and prediction from the configure. Batch files can be chosen from the training data and the files can be added here. After adding the files, the model can be trained from here and predicted prediction can be performed on the files from here. All the files, models, pre-processing steps that has been performed and used will be stored on your cloud and can be accessed from the file management part. As you can see, the folder for the training batch files, prediction batch files, the model that was used, the pre-processing pipeline that was used, everything will be stored here, and the final prediction file can be seen, can be accessed from here. And so the validation steps are that converting to the HDFS format is excluded when using the cloud storage. And firstly, the file name validation will be performed whether the file name matches the regular expression pattern performed while adding the project. The column names and the number of columns will be validated from the schema, and the missing columns, missing data will be pre-processed based on how we store data in the warehouse. And with the master data management, a master file will be created which will aggregate and pre-process the data with these steps. And finally, the file will be loaded in the warehouse. And during each of these steps, all the good and bad raw data will be stored in the cloud in the folders. After that, okay, this is the architecture of the platform where the where adding project can be the adding project steps can be seen from here. Retrieving projects will follow these steps. Model training will load the final training file from the warehouse. Apply the pre-processing steps from here. The pre-processing steps, few common pre-processing steps for both regression and classification are that removing the duplicate columns and the rows, missing imputation, which includes missing values, imputation missing values, missing data, removing the columns with zero variance, and removing the columns with perfect collinearity, one hot encoding, transforming the data, and this step can be excluded where a label can be added to the data. And after that, the target variable will be label encoded in case of classification. These steps may vary for the algorithm used or the type of the problem. After that, the prediction after this, the best model will be selected using the auto ML library designed. The architecture for this library is after the pre-processing steps, the final data will be split into the training and testing data using a ratio, and the training data will again be divided in and this is on this training data, three categories of models will be trained. The standard models can include models like linear regression, logistic regression, snake bias, etc. The boosting models right now include the XGBoost, and bagging model right now includes the voting classifier. And each of these models will again split the data into train and test, where the testing data will be used by the to cross validation. And after these steps, each the best model from each of these categories will be selected based on the CV score. And this this data, the best model from these will be selected based on the level 0 testing data. And now after training, the model will be uploaded to a model, and all the artifacts will be uploaded to the cloud, and a notification will be given on the first and the last step. The model training status will be given in the first and the last step. The prediction loads the master file from the warehouse. Apply the pre-processing steps used here. Okay, so the after loading the artifacts, the pre-processing steps will be performed. The model will be trained, and the prediction file will be added to the cloud, and the status will be updated. The library that was used for training the model can be found from here, which contain all the steps, and the metrics. The metrics can be found with the report management, and the view logs contains the log success logs, and the exception logs contains all the exceptions occurred during the whole process. And as you can see, the the process returns the R2 score, adjusted R square, mean absolute error, root mean squared error, and the mean squared error, and the best model name. The project was also hosted on cloud using the GCP, which can be accessed from here. Thank you.